take advantage of this session, this Q&A.
Nilanjan, I have one question for you. Yours was a very remarkable project, definitely one of its kind. Uh, if, if in near future similar project come, what would you like to do differently what you have done in this particular project? Maybe similar scale project if comes again. And any suggestions particularly to the terrain that the delegates who are doing project here across Northeast should keep in mind when they are executing these kind of projects? So twofold question.
Yes, that's a very good question actually. Obviously through the entire journey of this whole project, there have been a lot of challenges which probably we have foreseen before, some unforeseen. So I'll just try to deliberate on some of the unforeseen ones. So because the fabricator friend is over here, so he'll be able to actually vet that. One of the biggest challenges to understand the erection process. When we had envisaged the erection process, the transportation process, but for example, when you are going to erect with a tower crane, the placement of tower crane around the space, around the site, where you would like to place it and the erection sequence via the tower crane, very important. That is to be addressed absolutely at the beginning of the project, rather before even the design is done. That's one big thing. Second is that where the availability of sections, variation of sections, it might end up with a little more tonnage, but variation of section, try to reduce it as much so that the fabrication process becomes far more smoother. Having said that, I must mention that India's steel producers have made so much progress with the variation of sections. Even until 5 to 8 years back, the sections which were not available are still available in the market now, which makes it easier for any structural consultants over here or any fabricator, I would say, to get the product and to working on those solutions, I think, can really alter the project, and also study the entire terrain where the construction and fabrication would be done. I think that should help in most of the execution of the work of any project. Thank you. If there's anything else.
I just want to add, when Mr. Basu was speaking on the problems, we had problems, challenges in every level of the project. But the major problem was when we had to fabricate the secondary structure. You might have seen the drawing that there was a primary structure and there was a secondary structure. Though the secondary structure had the pipes to take the load, but the shape of the horse, the shape of the rider was to be given with steel. So to choose a section was a big challenge because we thought of going with pipes, we thought of going with any other thing. But then malleability and the ductility and then, bending it was a problem. Then we finally decided on flat. We went for flats. But now how to give the shape? There is no model, there is no design which can give you a shape that these are the coordinates, because you're working in space. It's an X, Y, Z coordinate. So how will you define that this section is bending here and it is a big challenge. So anybody from the audience can think of an idea how we can solve this? Anybody? I'm asking the audience if anybody is having any idea, any wild idea, how we can solve this problem of giving a shape. It's not a uniform shape, it's an ununiform shape to any object when you're fabricating or when you're making. Anyway, I will just reply on that.
Say that in case anyone has a better idea, like in concrete we have 3D printing, so in steel also we can have such type of 3D casting of that shape or that geometry, if I am correct.
Yeah, that would be a good suggestion.
It's a good suggestion, but we went for 2D because 3D was not possible because we had to use flats. So what we did, we took out the section, the topography of the section, the outline. We took out that outline of every part, every 300 mm, the outline was taken and it was printed on a flex sheet. A flex sheet as big as this room also, there was flex sheets of different sizes. as big as this room. It was printed in one single page. And that marking, on those marking, we put the flat and we bent it slowly. This is how it was solved. It's a very easy method, but it really worked out. Thank you.
I have a little question, Mr. Ram, Pekart. It is a good new technology that fiber reinforced concrete. In one of our flyover projects, actually, we started the DPR with the fiber reinforced concrete, but later we dropped because we are implementing for the first time, and it is at a very critical location.
Thank you for the question. The answer is yes and no. Steel fiber is not used in concrete to enhance the compressive strength of concrete. Steel fiber is not even used in concrete to enhance the flexural strength of concrete. Steel fiber only enhances the ductility or the flexural toughness in concrete. So that's the answer in a nutshell, if you want, what steel fiber does. When we all know that concrete is very strong in compression, but when the compressive strength of concrete goes beyond 40-50 MPa, the concrete starts to also become brittle. So beyond those grades of concrete, you want to have some element in the concrete which adds to the ductility so that the concrete is not failing explosively. And to arrest micro cracks and so on and so forth. If you talk about ultra high performance concrete that you already mentioned, concretes of 120, 150, 180 MPa, which have already started being used commercially in India. One of the projects in Pune have used ultra high performance concrete with our steel fiber. So that's already a commercial use that's already started. So what happens there is, because of the brittle nature of the concrete of such high strengths, you need steel fiber to impart ductility. That's the purpose. But steel fiber necessarily is not enhanced, it's not added to enhance the compressive strength itself. Compressive strength itself is achieved by the paste and something called a macro defect free, MDF. So you're reducing the aggregate sizes and so on and so forth. There are other technologies, we can talk about it subsequently outside of this. Coming to the codal provisions, steel fiber already is an accepted technology worldwide. Also in India, 12 million square meters is a testament to that. 12 million square meters have been already reinforced with our steel fibers in India. So that's a testament to the acceptance. In terms of the codal provisions, IRC SP46 is already a design guideline for steel fiber reinforced concrete pavements. So IRC, Indian Road Congress, already has one. ICI, Indian Concrete Institute, has come up with a TC9 guideline. We can talk about it again after outside of this podium, where this guideline also gives you design, practical, technical considerations in industrial flooring and usage of steel fiber for design of industrial flooring as well. So there is a document very well available, and Indian IS 456 also mentions that you can use steel fiber to enhance the properties of concrete, and that's about the Indian standards per se. But there are numerous international standards which are available to design with steel fiber in concrete to enhance specific properties of concrete. If that answers your question, sir. Yep. Thank you. Thank you.
My question to Parekh. Now, Parekh, you have done a good project, West Point in Sikkim, first of its kind.
I can't hear you. Can't hear you.
Hello. Now it is clear. Parekh, you have shown a presentation of West Point steel structure project, West Point project in Sikkim.
Now we have mentioned that there are few difficulties you faced while constructing this project. One is the material availability. It's because you have brought all the materials from all the way from Calcutta, and the erection because the national highway just beside that project. What are the other challenges you face in that project? That is number one, and one question. Number two is when we actually started doing the concept stage design, what are the things it came in your mind, why this project you have taken that the steel will be the preference for you to do this construction? And the third question is, if anything you want to change at this point, because the project has been done, so if anything you want to do a betterment for the project, what are the things that will be adopted at this stage?
Yeah, first question is why we went in for a steel structure instead of a concrete structure. Right. Actually, the entire site is in a hilly area where we have got a lot of space constraint. Transportation of material is a big constraint because of the narrow roads, winding roads, and availability of material in Gangtok itself is a big challenge. And the most important thing was it is a high-rise structure, and since it's being in a zone 4, we had to keep the weight of the building as low as possible, so that would generate less earthquake forces and will have less stresses on the soil also. Though the soil available there, we had a bearing capacity available was around 30 tons per meter square, and our load intensity, because of the steel structure, composite structure, we could restrict it to only 12 to 14 tons per meter square. So this was a major reason of our switching over from concrete to steel. And another thing was doing in a concrete structure, the amount of material which we would have to transport to the site for mixing and placing would be huge, and that space was not available on the hilly areas. No RMC was available there that we can do this. But primary reason was to reduce the weight of the structure as low as possible. Third was, the main challenge was the fabrication, erection and transporting the material from Calcutta to the hilly areas. We had to transport the material in 3 stages. One was from Calcutta to Siliguri, Siliguri to a place near Rangpo, and then from there again we had to shift the material to the site. And the major challenge at the site was the running road, because that was a taxi stand. And we could not stop the taxis from parking there, moving there, because it's a major tourist hub and the taxis have to ply from there only. So we had to keep the vehicles running, we had to allot them the space for parking. That was a major constraint. Particularly that constraint was further aggravated when we were connecting the road with the plaza, where we could not stop the traffic. So all the erection was being done at the night. And another most challenging task we faced in there was the rains, because the monsoons are very harsh there. So continuous rains for 3 days, 4 days, when the work used to stop. But for that particular connectivity, even we had a girder of a 20-ton single-piece girder which had to be erected. That was erected during the night time and during the rains. Otherwise, it wouldn't have been possible. And the time was the biggest constraint, because it was a Chief Minister monitored project, and it was a smart city project. It had to be inaugurated in this January only, and we had only 2 years timeline. So that was one of the very major challenge of completing it within the time zone. And we have been able to do that within 2 years.
Want to change anything in the either in design or construction perspective? What do you want to do?
If you have to change, see, the entire architectural intent has been satisfied in this particular structure. Structural framework you cannot change, but otherwise anything else you want to change, there is a possibility of changing. In fact, as you know, we have a mall there. So once the users come in, they have their own requirements. So the system we have developed there, we have been able to introduce escalators. We have been able to give them cutouts. We have shifted staircases. Those changes we have already done after it was fabricated and completed, because it is very user dependent. So this structure, you can make certain changes without touching the main frame. Thank you.
Sir, my question is to you again. Any estimate on how much was the steel consumption or what was the kg per square feet consumption of steel?
The structural steel consumption of 4,000 tons, sir. Around 10 kg per square feet.
10 kg per square feet, okay. And how much is saving if you see in terms of money, rupees per square feet? Was it a profitable decision to go for steel, or it costed little more but you saved on time?
Now, if we compare it with a fully concrete structure, you are comparing it with the RC structure as well as steel structure.
Yeah.
No, sir.
Any other alternative?
No, if we are, alternative is only a concrete structure vis-a-vis the steel structure. Concrete structure would have been much cheaper than this particular structure, sir.
Okay.
But the advantage with this structure was the locational advantage, which because of location we had this advantage of making it steel, making it lighter because of the zone 4. Otherwise, cost, yes, the cost has been phenomenal. 4,000 tons, you can imagine, it's a 10 kg per square feet. Virtually 1,200 rupees per square feet just on the steel part. Then you have the rest of the concrete and everything is there, sir.
Other cost remains anyways.
Yeah. No, there's no saving, sir. We could only save the time. We could complete the whole thing in 2 years. That is a major saving which you could attain.
Right. That's the main consideration.
Yeah, that's a major saving that way.
Perfect.
One question I have for the steel fibers which we use in pavements and ground floors. See, the problem of abrasion of the top layer, top coating of concrete once it goes off, how does it affect the performance? Like they will be protruding outside the concrete surface, or how is it handled?
The top surface in an industrial floor or a warehouse floor is typically hardened by using cementitious hardeners. That's a good practice to use good amount of cementitious hardeners to impart or improve the abrasion resistance of the surface. Nevertheless, the usage of any hardener or non-usage of hardener, there is an abrasion over years. There are cases where the usage of the floor itself eats up the top layer. And there are a few steel fibers that pop up on the surface and they are exposed. I would like to add 2 dimensions to it. One, because steel fiber is a non-discontinuous reinforcement, this doesn't impact the structural integrity of the structure. So anything exposed on the top, even if it corrodes, it doesn't transmit corrosion to the next fiber because it's a discontinuous reinforcement. So it doesn't impact in terms of the durability of the section or the structure itself. It doesn't have any impact for a few fibers to pop up on the surface. Number 1. Number 2, aesthetically, yes, it could have some steel fibers showing up on the top, but what we have seen over the years is it's not a major concern of our clients that a few fibers are coming up. And any fibers that are protruding are equally as or even softer than concrete. This is mild steel still. So any abrasion that's happening is also taking away the steel fiber along with the usage. So it's not going to puncture tires or things like this if that's a point of concern that you're raising, sir.
Thank you, and thank you audience for the questions, and hope the panel has answered properly. One more question. Yes, please, go ahead. Can someone pass on the mic?
So, not specific to one dignitaries, but some kind of answer I want to have. Thank you for partnering in the development in Northeast, all the construction companies. But what I see and what I got from this presentation, like one of the main enabler for timely completion of all this project is steel supply and logistics. Third is the associated infrastructure, fabrication and all. Okay, so from my experience, I have seen that steel supply part, though investment is happening in Northeast, but most of the steel supply is being made either from Delhi or Calcutta. So that revenue part, the Northeast not enjoying. Second part, the logistics. Also, logistics challenges are there. That's what the companies are sourcing the steel from there. Second, that lacuna that I find that supporting infrastructure like fabrication and all that is not developed in Northeast. That's why that revenue part also go to other cities. So it is my kind of query to the developer what they are doing. And of course the third part, the service part, you know, I have seen lot of engineers and the construction worker, they are also sourced from outside. So that third revenue part was also missing. So what the construction companies are doing to develop Northeast so that these three main component of the job creation and kind of boosting of Northeast economy is taken care of during the project, whatever they are executing. And if they are doing, that is, they can highlight, or if they can suggest to the authorities over there what they can do so that this part also Northeast enjoy. Yeah.
Yeah.
Church building, I just wanted to ask one thing. So,
the first step we are doing is to set up a steel construction summit in Guwahati. That's the first step we are taking to develop the Northeast in the steel segment. Having said that, Northeast has a huge consumption of steel. Your point of concern is very valid. However, just to iterate on that, for example, the structure in Gangtok, there are fabricators like Mr. Abhishek Agarwala in Shiliguri, in and around Northeast. They are there, but sometimes they are untapped. So the whole point of such summits are to bring them all on board, to give them a recognition, to give them a visibility, so that you understand that Northeast itself has a, sourcing of material. How it can develop is that it can set up the dealerships over here. There are a lot of dealerships in Calcutta, you're right, but there are dealerships who have extended their bases in Northeast as well. For example, we are working in Bhutan and we are sourcing from Northeast. It's not that we are going back to Calcutta or any other cities far. So, but yes, maybe it's slow, but the whole process has started. A lot of steel structures are coming up. Again, as I told you, the whole initiation of this, having this summit over here, getting eminent people like yourself over here, is to disseminate and ensure that steel is extended to Northeast and to the extreme part of Northeast. At least I think that's the first initiative we have taken.
No, I was also speaking on the same line, as in like when you speak of the sourcing of material, generally when we buy steel, we buy from the best possible place. So since south of Bengal, Durgapur area is a hub where iron ore is mostly found, so most of the plants are associated there. So for us, it is more economical when we buy from there directly. But yes, there are dealers in Guwahati, there are dealers in other places of Northeast who buy steel from them and they source it to the nearby areas. As far as your fabrication is concerned, of course, we are there, so you can rely on us. We can deliver you. We are close to Siliguri and it's a gateway to Northeast. So any material, anything fabricated from elsewhere, anywhere in India has to cross through Siliguri. So why not you give us the order and we will deliver it at a cheaper price.
Mr. Reddy, before you ask your question, I have one question for you, which I am sure the entire audience also would like to know about. So you have the first structure that you showed where you managed to, without, any further delay, you managed to erect the structure, strengthen it. What I want to know, or I think what audience would like to know, is on the first stage, why the problem occurred. So that is something that everybody would like to know, whether it was a design problem or it was an erection problem. And if we are designing something, some similar structure, how we can, avoid those?
yeah, that was designed by one PEB company. So they have executed without much knowledge about the design. So, and that was certainly a design problem. All the, columns were not designed for the slenderness inside columns, because there were, if you see the photograph, there were no tie beams in between, and also all the columns which are designed also very, very light. To save the cost, they have taken up the job, and that way they, compromised on the design part also. So we had to spend 55 tons of steel to strengthen whole of the structure again. So that was a really, it was a design problem. And one fine day there was a big wind, so it swayed like that. There was a lot of sway in that.
It was in one way it was good that it was open structure without any sheeting and all, otherwise it would have attracted more wind.
Yeah.
And one more issue can be that there is no code for designing of PEB structures at the moment in India. People are doing as per MBMA guidelines and all. So once this code, I think it is in the making, and once it comes, there will be a uniformity in safety and other aspects will be there. Yes, Amit ji.
Yeah. Mr. Harun, this is to you, but related questions on the similar line. See, what the kind of failure that we have seen has wind load acting along the shed. Okay. How does your structure, which do not have structural member at all, how will that respond to such wind requirements?
So we basically, when we do the self-supporting structure we provide, we don't just do it, we design it through a consultant or an engineer, so that the wind speed and the load which it can take, we decide it. And normally what happens is that we recommend for more than 0.8 mm thickness of sheets for this, so that the thickness, if the weight of the thickness is much more higher, then it can obviously take the load well and the wind speed also. So this is how we basically design the self-supporting this roof. Sir.
No, my question is still not answered. Yeah. The kind of failure that he has shown in the photograph, okay, how will you ensure that such failure don't happen in your structure? You can still have similar failures.
Our technical person is with me. He will let you know.
Okay. Or otherwise we can talk separate this things. Yeah.
Yes, I am Pawan. Actually, we check the deflection in the IS code. At the base of IS code, we check the deflection in the wind load of 180 km/h. And another is the dead load is we calculating 7.5 kilonewton per square meter. On basis of that, we are designing the same and decided what thickness is to be required for the roof. For this actually normal conventional roofing, if you say because customer want a 0.5 mm thickness or 0.45 mm thickness. But at the same scene, we in the trussless roof, thickness of the sheet calculating as per the span. If it span comes to 32 meter span, on that basis we are suggesting them 1.3 mm thickness material, because we are design the span with the thickness of the material only. So there being no issue at all, because 180 kilometer per hour will not is enough for our area.
In fact, I think Amit is still wanting to ask more. Maybe we'll take it offline, I think.
I have something to add on to this. Like as Sir said that, okay, yes, it has been designed. Of course, any PEB structure is designed for 180. If you go to cyclonic area, it is designed for 210 km/h. Design part is different. But any failure of PEB is not because of design, not because of fabrication. It is the most important thing is the erection. If you have seen any structure which has fallen after the complete erection is done, I have not come across any structure which has fallen down when complete bolt up and you have done all the fittings. It won't fall unless it is extreme conditions. It falls because of the problem in erection. When they do the erection, they do some kind of there is some kind of a loopholes in the erection. That is when the structure falls. Suppose there is a strong wind and the structure is not erected, because when you do the erection, as sir said, that the purlins were removed. You were trying to remove the purlins, right, in one of the renovations. So when you do the erection, you just bolt up slightly, you don't bolt up tightly. So those are the most vulnerable time when a structure will fail. So that is my experience, and rest all is up to you.
One thing I would add that construction stage safety also takes a very important role while designing. During construction, which will be maybe over 6 months or a year. So during the construction, all such possibilities of failures are also taken into design. If one does that, chances are minimized. And also, like we have seen, lot of temporary structures, large exhibition sheds we call German hangars are being built. So again, wind load is same, it can come anytime. So those are also safe, which will look very light and very, very flimsy type if we see, but they are also safe. So the key lies in proper designing, proper execution, and proper QA checking also plays a very important role.
Mr. Reddy, if with the permission of session chairman, last question you had for Ravindran so that we can break for lunch.
Yeah, that's it. Yeah, Mr. Ravindran. So actually, I just wanted to understand how you have erected it, because it's a very difficult structure, I believe. So even for the design also, and then even erection also, can you throw some light on that?
Yeah.
Erection.
Actually, I would say black magic. Because see, the problem was customer had this peculiar requirement that they wanted to do up to 4.8 meter in RCC. Okay. So the RCC structure was already done. So we couldn't take the crane inside and do the erection. We had to do it from outside. So we actually erected, especially the front 2-3 arches were having the highest diameter, the highest being 57 meters clear span. And the arches themselves were fabricated in segments. So they were, the first arch, if I remember correctly, was in 7 segments. So what we did is we erected, we assembled 3 arches first time, and then the crane was parked outside. We had to get a little higher capacity crane. The crane was standing on the side of the building. That erected it, and then after erection we had to give it a support. We had to fabricate, and for that height we had to make a support, make it stand there, then bring the crane on the other side, erect the other side, and assemble it. It was quite a circus. Yeah. And in such projects, since somebody was telling what you could have done better, I would, I was thinking in my mind what I could have done better. 3 things: planning, and more planning. Anything and everything that can go wrong will go wrong. Because crane, and especially places like northeast, remote places, probably Sikkim, he must have had the same problem. Nagaland we had. Crane guy will not come. Rain is there. Your erection labor team will act up. Even a 8.8 grade or 10.9 grade nut bolt is not available in the place. You have to go for anything you have to come 300 kilometers to Guwahati. Even in Guwahati, many times these things are not available. So lot of planning is required. That's one challenge of working. Out in mainland, you really don't bother. Hardware and everything, a phone call away, you call your head office, they will send it. Yeah, it's not like that here. So that's one of the challenges. Yes.
Is it a triangular based truss or a
Beg your pardon?
Truss? How you made?
It's a double I section.
Double I sections.
So double I section.
For a lateral stability, how you have taken care?
If you are going into structural engineering question, then I have my friend with me.
Okay. Yeah. Thank you.
We can take it offline. Yes, sure.
Okay. Thank you.
I think rest of the things we can take during the break and maybe in the evening.
Very, very well coordinated session. Very interesting.
Thank you all the speakers for enlightening us in the various areas which you have specialized in. And with the permission of the chair, let me close this session. Thank you.
Thank you.
Thank you. I think this was the challenge which I, when Amit ji and Avneet ji contacted me to chair the Super 7, I got scared because in the last few events, it was a very difficult task. So I thank all the speakers for average maintaining the time schedule. Thank you.
I think I would like to thank Mr. Sinha. Not only did he make sure that the time was maintained, he deliberated and summarized all the speakers with amazing knowledge of his also his sharing experience, yet not exceeding the time, encouraging the speakers, and that's why I would say his was the worst and the most difficult job, but well done, and the speakers get inspired by Mr. Sinha. Thank you so much. And Mr. Sinha, of course, is a man of huge repute with huge experience. It was an honor being chaired by him. Thank you, sir.
Thank you, sir. Thank you.